Hello everybody, welcome back. Today we're taking a look at lesson 6, which is solution stoich. Now, we've been doing solution stoich in unit C and unit D. However, for some reason, students struggle with this type of stoich the most, even though we've seen bits and parts of it already. Before we get started, let's do a review of the other stoich that we've learned, and then we'll move into solution stoich. Okay, you can go ahead and fast forward through this if you don't need it, and then we will move into the real one. Okay, review. Sodium metal, hydrogen gas, and oxygen react to form sodium hydroxide. Okay, so this is a formation type of reaction. You can have 3 or more elements coming together to still form something. If 28 grams of hydrogen reacts with what mass of sodium hydroxide is produced? Okay, let's write our reaction first. So sodium metal plus hydrogen gas and oxygen gas react to form sodium hydroxide. And then let's balance this. So we're going to need 2 and 2. If 23 grams of of hydrogen gas reacts, so let's list that here. 28.3 grams. What mass of sodium hydroxide is produced? So I'm going to leave some space underneath there, but I have pretty much have everything that I need from my reaction. The next thing we're going to do is write our stoich statement. I'm going to start with my known. 28.3 grams of hydrogen gas. Okay, if you have a mass, if you have volume of a gas, what you first have to do is convert it into moles. We do that by using molar mass, which is 2.02 grams per mole. So I divide by 2.02 grams over mole. What's canceling out here? Grams cancels out, and I currently have moles. I highly recommend that you cancel out units as you go, because at the end, students just like to randomly cancel out units and you don't know what you actually were supposed to cancel out. From there, we're going to use mole ratio. 1 mole of hydrogen gas to 2 moles of NaOH. Also, when you are canceling as you go, you can see if you've made a mistake. You don't need to write the whole statement over again. So moles cancels out with moles, and hydrogen cancels out with hydrogen. Perfect, we have moles of our unknown. From here, you're going to use molar mass because we're looking for grams. So the molar mass of sodium hydroxide is 40.0 grams per mole. So I'm going to multiply by 40 grams over moles. Moles cancels out with moles, and I'm left with grams of sodium hydroxide. Once I plug this in, I'm going to round my answer to 3 significant digits. My final answer will be 1.12 times 10 to the positive 3 grams of NaOH. Lovely. Let's move on to the next review. Okay, so the review for this is emphasizing that if you want to go between grams and moles, doesn't matter if it's gas, or it doesn't matter if it's been dissolved, or if it's just a solid. If you want to go between grams and moles, you need to use molar mass as your converter. Lovely, let's move on. 1.29 0.9 kilograms of magnesium oxide decomposes. Determine the volume of oxygen produced at SATP. Write your answer in the form of A.BC times 10 to the D liters. Okay, first thing we're going to do is write a balanced reaction. So magnesium oxide decomposes to form its elements. So it's composed of magnesium and oxygen gas. Let's balance this. Okay, now what we're going to do is label our known and unknown. So we have 1.29 kilograms of magnesium oxide. We are looking for blank liters of oxygen, not kiloliters, liters of oxygen produced at SATP, which is 24.8 liters per mole. Great. Before I get started, I know a lot of us would prefer to be comfortable without those kilograms. So we're going to convert this into grams. Okay, so to get grams, all you have to do is multiply by 1,000 or move the decimal point 3 times over, and you get 1,290 grams. I'm going to cross this out because that's the same information and I don't accidentally want to use it twice. Let's begin our stoich. 2 1,290 grams of magnesium oxide, and you're going to use molar mass to convert this into grams. So I'm going to go ahead and find the molar mass of magnesium oxide. I like to list it underneath here. Some of you can go ahead and pop it directly into the stoich statement, but I'm doing this just to show you where it's coming from. 40.31 grams per mole. Grams and grams cancels out. We're left with moles. This is your opportunity to use mole ratio to convert to the unknown entity. You divide by 2 moles of oxygen, and we have no coefficient in front of it. That indicates that it has a coefficient of 1. I hope that we are able to get this. I made a mistake here. That should not be oxygen. It is 2 moles of magnesium oxide. Let's see what's canceling out. Magnesium oxide cancels out with magnesium oxide. Mole cancels out with moles. Lastly, we are looking for liters of oxygen. So we're not going to use molar mass. We are now going to use our molar volume. So I'm going to multiply by 24.8 liters over mole. Mole and mole cancel out, and I'm left with liters of oxygen, giving me a final answer of 397 liters, 397 liters of oxygen gas. Now it wants our answer to be in AB.C times 10 to the D liters. So that would be 3.1297 times 10 to the 2 liters of oxygen gas. If I were to take this and write a numeric response with it, that would indicate that there are 4 digits. That would be 3972. Notice how I've put no decimals in this. I have just directly transferred the numbers. Oh, last thing that we want to emphasize here, this example is going over converting from liters to moles, and this is liters of a gas, you will be using molar volume as your converter. Okay, so Stoich, what it's all about is selecting the right unit converter. Okay, in solution Stoich, we will use molar concentration to convert between volume and moles. Okay, so going on here now, we're going to have volume of a solution. So volume of a solution. So this is different from a volume in a gas. So volume of a solution, and we want to convert it to moles. The correct converter to choose is molar concentration. Okay, so it's all about making choices. Okay, example 1. What volume of 14.8 mole per liter ammonia is needed for the ammonia to completely react with 1.50 liters of 12.9 mole per liter phosphoric acid to produce ammonium hydrogen phosphate? Okay, first thing we're going to do is write a balanced equation. So we have ammonia. Okay, it's in solution, so it's aqueous, plus phosphoric acid. Acids are also aqueous in solution. You know that you're working in solution because it's talking about concentrations. You need to see if there's any precipitates or see if they are aqueous. And then it produces ammonium oh wait, that should not be a 3. NH4, so ammonium phosphate, which is also aqueous. Lovely. From here, we set up our known and our unknown. So we are looking for what volume of ammonia. So we're looking for liter of ammonium, which has a concentration of 14.8 liters per mole. Lovely. And then it reacts completely with 1.5 liters of phosphoric acid, which has a concentration of 12.9 moles per liter. Okay. What we're going to do from here is find the volume. You're always going to start with what's known. And what's known is what's given us the more information. This is our unknown because we are looking for liters. Okay, so by default, the other one becomes my known. So starting off with my known, I have 1.5 liters of phosphoric acid. And that's in concentration, so I will be using my, and that's in solution, so I will be using my concentration to convert this into moles. So I multiply by 12.9 moles over liter. The most common mistake that students make is they switch the numerator and the denominator when using concentration. So please be careful. The 12.9 is staying with the moles. Okay, what's canceling out? Liters and liters. And this is why I recommend that you are canceling out as you go. Then, once we have moles, you're going to use mole ratio, which always reminds me I haven't balanced my reaction. So, I believe a 2 goes there. We are going to divide by 1 mole of phosphoric acid, and we are going to multiply by 2 moles of ammonium. Okay, let's see what's canceling out. Mole cancels out with moles. Phosphoric acid cancels out with phosphoric acid, and I currently have moles of ammonia. Great. We are looking for liters, and because this is in solution, you need to be using concentration. So I'm going to go ahead and I wrote the units for concentration incorrectly here. Remember, concentration is moles per liter. And molar volume is the other way. And it's also in the problem. I just wrote that incorrectly. You are going to divide by 14.8 moles, and liters goes on top. Mole and mole cancel, and you are left with liters of ammonia. Once you plug this all in, you get an answer of 2.61 liters of ammonium. Okay, let's do one more. Sulfuric acid reacts completely with 15.9 milliliters of 0.150 moles per liter of potassium hydroxide solution. Calculate the concentration. Remember, square brackets means concentration of sulfuric acid. Just like every problem, let's begin with writing a balanced reaction. So we have sulfuric acid reacting with potassium hydroxide. Now, what is it producing? This is going to be a double replacement reaction where your positive ions are going to switch places. So these two are going to switch places. You are going to produce water, and you're going to produce a salt, which is going to be potassium sulfate. Okay, so now we're going to list, actually we're going to balance everything. After balancing, I believe I get 2 potassium hydroxides and 2 potassium sulfates. Nope, not 2 potassium sulfates. Sorry about that. You get 2 waters. Okay, let's list things. 10 milliliters of sulfuric acid. Reacts completely with 15 milliliters, 15.9 milliliters of 0.150 moles per liter of potassium hydroxide. Calculate the concentration, so we're looking for concentration of sulfuric acid. I kind of like the solution Stoich better because you don't have to calculate any molar mass or you don't have to calculate any molar volume. Let's now go through and start with our known, this guy here. 15 milliliters. Now I'm going to do this with milliliters just to show you that you can do Stoich with milliliters. Because we have milliliters and milliliters, you'll see that the milliliters cancel each other out. If that confuses you, go ahead and convert milliliters into liters. So I'm going to begin with 15.9 milliliters of potassium hydroxide. I need to convert this into moles, and I'm going to use my molar concentration. So I multiply by 0.15 moles per liter. What cancels out is liters and liters, and I'm left with millimoles of potassium hydroxide. Now that's okay because the base unit is moles. So we can go ahead and then convert into our unknown moles by using our mole ratio. I'm going to divide by 2 moles of potassium hydroxide and multiply it by 1 mole of hydrogen sulfate. From here, I am going to then be able to cancel out moles and moles and potassium hydroxide. That leaves me with millimoles of my sulfuric acid. Then I then I need to convert the millimoles into moles per liter. So I'm going to use this. I need liters to be on the bottom. So I'm going to divide by 10 milliliters. Okay. And on top, you're going to have your moles. No, there's no moles. That's a volume. Okay. So I'm going to divide by that. Now let me show you what happens. The milli cancels out with the milli, and you're left with moles per liter of of sulfuric acid. Once you plug that in, that gives you 0.119 moles per liter of sulfuric acid. Okay, I have the other way on the filled PDFs that are on D2L. So if you want to see how to do this the other way, but I wanted to walk you guys through this version through video, and then the other one is on the filled in PDFs. All right, you're going to try this one on your own. 15 milliliters of sodium chloride reacts with 35 milliliters of 0.525 lead nitrate. Determine the molar concentration of sodium chloride. So remember, first step, you're going to write your balanced reaction, then list what you need. Then you're going to perform Stoich and find your unknown. Okay, so you can unpause when you are ready. All right, so first thing you do is you write a balanced reaction. You list your known and unknown. I went ahead and converted my volume into liters this time, just so you could see it. But if you use milliliters, you should get the exact same answer. So then we started off with our known, and then I used concentration to convert it into moles. Once I had moles, I then used mole ratio to convert my moles into moles of sodium chloride. Then I divided by my volume so that I would get concentration, which is 1.17 moles per liter of NaCl.